Okay, ladies and gentlemen, you're most welcome once again to my channel. It is still your tutor Peter Ikaja. It's been a while since we had our last video, but today I am actually back in full swing and I've been receiving requests from most students talking about integrals of even powers of sine x and cos x. They also talked about odd powers, but in this video, I'm particularly going to take you through even powers. Without wasting a lot of time, before you know how to integrate even powers of sine x and cos x, you need to first know the basics. And one of the basics is remembering that from cos of 2x from our trigonometry is equals to 2 cos squared of x minus 1. Cos squared of x is actually supposed to be 1 plus cos of 2x divided by 2. Very important in the application of the integration of even powers. Then the other one that we need to know is that if I also have cos of 2x again, which can as well be written as 1 minus 2 sine squared of x from double angles, then sine squared of x is definitely going to be 1 minus cos of 2x divided by 2. Now, once you know this, it becomes so easy for you to handle integrals which have even powers, as long as they are even powers of sine x and cos x. Let's begin right away with a few examples that we shall quickly look at in this video. Examples, for example, number one. Number one, we have a question saying find integral of sine squared of x dx. Now, definitely, when you're given such an integral, it's obvious to realize that uh, integral of sine squared of x dx is as good as integrating 1 minus cos of 2x divided by 2 with respect to x. This means a half is a constant. It can go out of the integral sign. So we shall be integrating 1 minus cos of 2x. And that means we are integrating with respect to x. At the end of the day, you will have a half into brackets. Integrate 1 with respect to x. You will get x minus integrate cos of 2x with respect to x. You will actually get sine 2x but divided by the derivative of the angle, and so plus an arbitrary constant of integration. That means when you open the brackets, you will have a half x minus a quarter sine of 2x plus a constant. That becomes the integral of sine squared of x with respect to x. So it is as simple as this. The next question. The next question can be finding the integral of actually cos squared of x. Finding the integral of cos squared of x. Now, if you're to find the integral of cos squared with respect to x, it's a matter of knowing that cos squared x is actually the same as 1 plus cos of 2x, all this divided by 2 with respect to x. A half being a constant, you can have to have it out of the integral sign. Integral of 1 plus cos of 2x, all with respect to x. Now, if you have this, then you now integrate 1 with respect to x, you will have x. Then when you integrate cos of 2x with respect to x, you will get sine 2x, but you divide by the derivative of the angle plus our arbitrary constant of integration. That means at the end of the day, we can all know that cos squared x dx is going to be a half x plus a quarter sine of 2x plus our constant of integration. Now, what happens? What happens if someone gave a situation like integral of, let me say, someone gives a situation like this. Someone tells you find the integral of maybe cos squared, but of 2x. Now you need to remember that now that we have 2x here, this definitely becomes the integral of 1 plus. Now we double the angle. So it will be plus cos of 4x. All this divided by what? By 2 with respect to x. At the end of the day, a half comes out. So we shall integrate 1 plus cos of 4x and then with the respect to x. Please don't forget the respect of integration. So from here, we can definitely now say this is a half. Integrate 1 with respect to x, you get x. Integrate cos 4x with respect to x, you get sine 4x. But remember, you must divide by the derivative of the angle and then plus a constant. At the end of the day, when you open the bracket, you will have a half x plus 1 over 8 sine 4 of x plus a constant. And when you do that, you will have already done the integral of cos squared of 2x dx. Now, in the remaining few minutes, I will give you a few questions to try out also so that you can perfect, because practice makes perfect. So you will try for me out the following questions. You will try out the following questions. I will call it a simple exercise. You could find for me the following integrals. Find, particularly, I'm going to say sine squared of 2x dx. Roman 2, you can as well find for me the integral of cos power 4x dx. You can as well find for me the integral of sine power 4x dx. Roman 4, you can find for me the integral of sine power 4 of 2x with respect to x. And then you can as well find for me the integral of cos power 4 of 2x with respect to x. We can try out these questions, and in case you find any challenge, please, you can find me through very many platforms. You can use our YouTube channel, commenting. You can actually visit my website, that is www.peterikaja.com. You will find us there. Make a comment on the chat, and then I can respond to you. In case all that fails, you can as well get to me through the following contacts. This contact is on WhatsApp, or you can as well use 0784792369. Remember, we also offer one-on-one online tutoring services for students from all parts of the world. We have and follow different curricula, and we guide you depending on which curriculum and then the syllabus that you follow to prepare for your final exams. For today, I want to say bye-bye. See you in our next video as we shall talk about odd powers.